lecture, I'm going to show you how to make some basic plots because we're going to be exploring a lot of different data sets, and it's kind of useful to see this as early as possible, especially for those of you that want to play around with it on your own. For those of you in Gen Phys, you'll be using this code actually in your labs, and so you'll see it both there and in this class. Now let me acknowledge that some of the stuff I'm showing you is a little bit of what's called a black box approach. In other words, I'm not really explaining to you exactly why you would want to type it that way in Python. That will happen over the course of the next few weeks as you learn the details of the Python syntax. But what I'm going to show you today is something that you could potentially use to go ahead and just start making plots of your own, and if you're very careful about how you do stuff, you can format those plots how you like, make changes to them without knowing all the details. And then again, as the semester goes on, you'll learn more of those details. Okay, so you have a Python notebook that's been shared with you. This introduction to plots and plotting with error bars. We're going to be using what's called a library. This is a set of programs and Python code that allows you to make plots, and you'll be able to see this all on the Python website, or sorry, the matplotlib website. If you go to that page, the matplotlib page, you'll find that there's all sorts of information and extra documentation about how to make those changes. So you can go ahead and for those of you that, again, want to go a little bit further, you'll find this great cheat sheet of how to make different plots, how to do different color coding. One of the places in particular you might want to check out is either the tutorials or the examples. And these examples are actually linked to from the main Colab notebook, and it is all of these really, really nice demonstrations of how to make different plots. And so if you wanted to learn how to make like a bar chart that kind of looks like this, if you click on it, it will actually show you the Python code. And so if you take a whole bunch of this and you just like cut and paste into your Colab notebook, as long as you get all of this, you'll find that it works and it would produce a plot like this. And there are all sorts of examples on that page. And as you learn more Python, again, you'll learn kind of like why some of this stuff is the way it is. But really, you can just cut and paste this into your Colab notebooks. And if you get everything, you'll find that it works really nice. Okay, so going back to our Colab notebook, I'm going to show you how to make some basic plots. The two that we're going to focus on is a basic scatter plot. And I think you'll recognize what it is, where you just have a bunch of different points and you have to give the X and Y coordinates. And then we could even show you how to plot math functions. What we'll do is just plot a straight line, a linear function. And then going forward, you can, in subsequent lectures, we'll see how to plot more complicated stuff. I'll also show you how to do a scatter plot with error bars, because error bars are very important if you're doing any sort of scientific research. You'll also want to know how to label your X and Y axes, change the ranges. That means like zoom in and zoom out on parts of your plot. Change the fonts on your axis labels if they're not readable. Add a legend, a title, marker and line colors, and marker styles. And that covers pretty much most of the formatting that you might want to do, most of the customization of a plot. We'll go into this more detail later on, but I'm going to show you how to import some libraries, or as they're more often referred to, modules in Python. So when you first start using Python, it can do some addition, some multiplication for math type stuff. You can print out different words, do a bunch of different loops, which we'll learn later, but it doesn't do plotting, let's say, out of the box. To do this, you import a module. In other words, it's kind of like on your phone. Your phone can like make some texts and make phone calls, but you have to install apps like TikTok, Snapchat, whatever, if you want to do more things. These apps in Python, as I mentioned, are modules or libraries. And to install them, we just have to use the import function. So right off the bat, we're going to import matplotlib, which is that plotting library, and we're going to call it PLT. We're actually going to use a subset of those functions called pylab. Once we bring it in as PLT, we only need to type PLT to make our plots. So it saves us typing this whole thing out each time. Similarly, we're going to use a Python or a library called NumPy, which is numerical Python. We're going to import it as NP. And again, we can just do this. We'll be able to just then type NP to get all the functions. So I'm going to do Control Enter to run my module, to run this cell. This had the little dashed line, and then we've run everything. So we'll start off by making some basic scatter plots. So imagine you have some subset of data. The x and y coordinates for 1 point are 0, 2, 1, 3, 2.3 and 5, 3.5 and 4.6. So again, these might be some x values and the corresponding y values. And the way we enter this into Python is we use, in that NumPy library I mentioned, there's an array object. So what you want to do is you can call this x or x points or x values. I'm just going to refer to as x to make it easier. And we'll do np dot, that's not a comma, array, parentheses, and then in square brackets your x values separated by commas. So notice that we're going to take 0, 1, 2.3, 3.5, 0, 1, 2.3, 3.5. And we're going to take that all from the x values. And then we're going to do a similar one for the y values. And you want to make sure you have commas between them. Now this right here is just text, so it's really up to you. I'm going to ask you to type this in. So x equals np.array. And then 0.0. You could just do 0 if you wanted to. 1.0, 2.3, and 3.5. And if I hit Shift Enter, it'll advance me to the next line. But this is now part of, like, Python kind of knows about this. Now, I'd like you to go ahead and type out the Y array. So I'll ask you to, like, pause the video, see if you can do the same thing for these Y points. All right, go for it. Okay, so if you typed in everything correctly, you should have your x points like this. This is np.array, and again, there's commas between these. You don't have to have the spaces. You could, if you wanted to, just have no spaces between them, but I think it's a little bit more legible if you have those spaces. And then I enter in these y points right here. I'll set a new variable y, 2.0, 3.0, 5.0, 4.6, just like we had in that column. And I run this, and now I've got these points. Now, I haven't done anything with it yet. I'm going to now use these in our plot. I've pretty much copied everything you need to make your plot, so you really shouldn't have to edit anything down below, so long as you've entered in these points correctly. You'll see that every now and then I have these comments, as I did before. Those get color-coded green. They start off with a hashtag. So if you are colorblind and you can't really see the color differences, just know that everything preceded by a hashtag is not actually read as Python code. It's just like little notes that you leave for yourself. And the options I'll explain is how to set the color of a marker, how to set the style, that's the shape of the marker, how to change the marker size, how to set the axes labels. You do not want to hand in any plots, either here in your physics classes or any classes without labeled axes. How to set the label of the overall plot as it would appear in the plot legend, how to give it a title, and how to change the range or limits on the x and y axis so you can zoom in and out. And so the first thing we do is we make an empty figure. That's plt dot figure, and notice there's this open close parentheses. This next line actually makes the plot right here. So plt plot, the first two values separated by commas are your x and y points. The B0 is a formatting code that tells you to use blue, and then the 0 is for dots, or the O is for dots, sorry. Marker size 10 here gives the size of it. You could change it to 20 if you wanted to increase the size of your dots. And then the label is what's going to be used in the legend. So we're going to call this my test data. We'll give the labels a slightly bigger font size because they tend to be small. So you do plot x label. I'm just going to call it, this is the x-axis for now. And give it a font size of 18. You can play around with the size to see what the different sizes look like. Do the same thing with the y-axis. And then to zoom in or zoom out, what you do is you change the range for the y-axis. The y lim, this stands for y limits. And And so if you wanted to, you could change this from -1 to 5, -2 to 8. That's just to kind of give you an example. If you wanted to zoom in or zoom out and see what that looks like, you could play around with that. Here's the title that goes at the top of the plot. And then the legend does not show up unless you actually call this plt.legend. And so if I just go ahead, I haven't actually changed anything. It makes this plot. Here's our 4 data points. This is the x-axis. This is the y-axis. My test data with these, it shows you what marker we're using here. This is my first plot. The range down here for x goes from -2 to 7, just like we have up here. The y limb goes from -1 to 8, just like we have there. And I'll go ahead and make some of those changes. You could change the marker size to 20. You could change this range here from like -1 to 5. You could change this from -2 to 8. And you'll just see that it zooms in on a slightly different region now. Y limit goes from -2 to 8. You notice our marker dots have gotten bigger. So that's how you make a basic plot. Now let's make some changes to it. This is now up to you to make some changes. After you make sure that this is right, if you are not getting this, you can check with either me over Slack or any of the other communication methods, or post and maybe your peers can help you out. Now, I'm not going to ask you to change the data points, just the options. So we want this to look differently, but with the same data. So what I would recommend you do, if you haven't already, is cut and paste all this plotting code from above and then make the minor changes that you need to. I'm just going to change this formatting here. So here's what I'd like you to do. Make the markers into upward facing triangles, and you can refer to this web page link for the options, and make the markers red. So if you go to this section on base colors, again, I'll let you go to the web page. You can see what the different options are and figure out how to make it red. Make the marker size 20, make the plot label. So if that's for the entire figure, be trial 1, that's the entire one. Make the x-axis label be time in seconds. Make the y-axis label be position in meters. And then change the x and y axes ranges to just be 1 below the smallest value on the coordinate and 1 above the largest value on the coordinate. And make the title be lab data. So again, this plot label is what you would put under label for plot, but this is for the title of the whole thing. I will now let you go ahead and make those edits. Okay, so if you've made those edits correctly, you'll see we have our same 4 data points. They are now red triangles with time in seconds. So maybe this is some lab you're working on, some data you've collected. Time in seconds down here. Position, oh, that should be position in meters there. Make that edit right there. It's my mistake. And then we've called this trial 1, and then notice up here the title is lab data. So the lab data is where we put plot title. Trial 1 is where we put this. And I'll leave this up here now if you want to pause the video and compare it to your work. Notice we're using R for red, and this little caret symbol here, which on my keyboard is Shift 6. That gives us the upward facing triangles. Okay, there's more that you can do. You may want to plot more than one set of data, and all that means that you have to do is label things correctly. So in this next section, you're going to plot 3 different data sets on the same plot, and many things are the same, but we need a name for each data set. So I have one array called x0 with 4 data points, one array with 4 data points that I'm calling y0. So this could be your first set of data. It's the data that we just had before. I've got a second set of data, but I need to call it x1 and y1. You could have called these, x1, y1, x2, y2, x3, y3. Just so long as all the labels are different, you could have called this a and b0, or a and b1, or a, b, c, d, e, f. But it might be confusing then. So by using x and y values, I remind myself that these are like x and y points on a plot. We still make the empty figure, but now we call the plot function 3 times, where we pass in x0, y0, x1, y1, and x2, y2 for the inputs here. I give them different labels, trial 1, 2, and 3, and notice our format is different. We use the red squares, or red triangles, the blue circles, and here we will have green squares. We only have to do one x-axis label, one y-axis label. We set the limit for everybody. We give it a title, and if we run everything, we now have trial 1, 2, and 3 with our red triangles, our blue circles, and our green squares. And so if that didn't make as much sense to you, I encourage you to take the time to pause the video and rewind it and go back to make sure you understand stuff. Notice I still have this time in seconds down here, so why don't we go ahead and make these edits. Okay. Now it says position in meters. You could also plot straight lines. So if you wanted to plot a linear function, we can give it with a dash option instead of a circle, square, or triangle if we wanted. Later on, we'll use this if you want to draw like a straight line as in a fit. So we're going to take our original data and just estimate a straight line that goes through. I've written out the code for you, so you shouldn't need to make any edits, but I encourage you to make sure you take the time and understand what I've done. The first thing I'm going to do is I'm going to define my data again. It's still, this code would still remember it from earlier, but I'm just trying to keep everything in one cell for you. We're going to make the empty plot, and then we're going to draw the data with a K and then the little dash line. K is for black, and then this is going to draw a connected line for stuff. You could also do dash dash for a dash line. We could have left the marker size in there. It wouldn't affect things, but since we're not using markers, I've just taken it out to keep this simpler. So we just plot it with a connected line at each point. You're not going to see like a little circle or square or anything. And then we're going to draw a straight line, and now I'm going to make a different array of only 2 points. So these points are going to go into our plot function, and there's only 2 values. For our x value, you've got -1 and 4, and 1.5 and 6. And what this is going to do is it's going to draw like 2 points and then draw a line between them. We'll draw a red dash line. So we're just using the same plot function, but we're going to use these x line points and y line points. I will fix this right here with the formatting. And then when we run this, I did Control-Enter to run everything. Here's our original points, if you remember what they look like, but they just have a black line connecting them. And then I drew this red dashed line. And the red dashed line started at, for an x value of -1 and 4. So x -1, and it goes to an x value of 4. Our y points were 1.5 and 6. So it goes from 1.5 to 6 here, and that defines the dash line. So even though this is a straight line, it's possible that some of you already see how we might be able to draw more complicated mathematical functions just by defining all of the x and y points. Now, eventually you will probably want to do something with error bars, which means we need to use a slightly different function. It's called error bar with no spaces. There's more information here at the official documentation. So imagine now you have your original set of data, but you have an uncertainty on the y values. You can also do uncertainties on the x values, but we're just going to worry about y error bars because that's mostly what you have to deal with. And let's suppose we've been able to determine the uncertainty to be 0.2, 0.3, 0.35, and 0.45 respectively. So what you want to do now is to define 3 arrays, your x and y values, which will be the same as before, but let's call a new one called y uncert. And this will be our y uncertainty values. And so right now you should take the time to go down into this cell and make 3 arrays, x, y, and y uncert with these values. And I'll let you pause the video to go ahead and make those entries on your own. Okay, if you've entered in everything, it should look something like this. If you want to, you may even want to line these up just to help yourself see that you've got 4 data points for each one. You do not want to have like 4 points here and 3 points down here. So we have this new one called y uncert. Maybe you want to call it y error down the road, or ye or yu if you want. But I spelled it out as y uncertainty just to remind ourselves that this is the uncertainty that we measured on our data. So we'll use the error bar function. It is very similar, except for a couple of small differences. One, you pass in your x, y, but then there is an extra term here, y error, for the y error bars, and that equals the y uncertainty array that we passed in. And then unfortunately, we can't just write like B0 or BO or B caret for the squares. You have to have this FMT in front of it that stands for format. So we'll do format equals, and then we'll do this with blue triangles, and then everything else is the same. If we run this, we get my test data, and then we've got our points here, and then the error bars that go through them. And you will find that this is probably one of the more common plots you'll make, particularly those of you who are taking Physics 1. So hopefully you were able to get through this and were able to do some of the entering on your own of the data and making the edits without too much difficulty. If you have any questions, please reach out to me either on Slack or through any of the other means, or just post it on Slack or somewhere else, and it may be that one of your peers is able to even answer your questions before I do. Okay, good luck with everything. See you soon.